Hi, welcome to another session of Circuits and Networks. In today's class 7, under GATE exam problems and solutions on passive elements, we are going to see some basic numericals which were involved in past GATE exams and how to solve those numericals in a less time frame. So the first problem you can see here, the problem was asking GATE 2010 for 1 mark. As shown in the figure, the resistance is connected across a source that has a load line V plus I equal to 100. The current through the resistance is. So the options were given as 25 amperes, 50 amperes, 100 amperes and 200 amperes. For this, you look into the figure, you have a source here and current is flowing through the resistance 1 ohm. So I can apply KVL to this closed loop and I'll get minus V plus 1 into I equal to 0, thereby framing an equation 1 which is nothing but V equal to I. Also, given load line, that is V plus I equal to 100, that I will take into the account and I'll make this equation as 2. Now substituting equation 1 in equation 2, I'm going to get V plus V. Why? We have V equal to I, so wherever I is there, that is replaced by V. So V will be equivalent to 100 by 2, that is 50 volts. Once we obtain the value of V as 50 volts, we obtain the value of current I as 50 amperes. So option B is the right answer. In the next problem, three circuit elements shown in the figure are part of an electrical circuit. The total power absorbed by three elements in watts is dash. So this question was asked in GATE 2014 under set 1 for 1 mark. Please look into the diagram. You have 100 volts. In that 10 amperes is flowing. You have 80 volts in which 8 amperes is flowing in opposite way and 15 volts is given. So from the given circuit, we need to derive some of the inputs, and based upon that we can find out the total power absorbed by the circuit elements. So the solution starts with the given circuit. Let us assume that X current is flowing in 15 volts in this direction. This is an assumption. You can have your own assumption. So this particular circuit I have considered in this fashion. I'm concentrating on KCL because 10 amperes is given, 8 amperes is given, and what is the current which is supposed to flow in 15 volts. For that, I have assumed the direction of X current in downward direction from this particular node. So that is considered over here. So X is flowing over here. So applying KCL, I'll get X which is coming out of from this particular node, and you have 8 amperes which is also coming out of this node, and that is equal to 10 amperes. With this, I'll get the value of X as 2 amperes. Hence, the value of current which is flowing in 15 volts is 2 amperes, and the direction of the current, it is taken according to the assumption what we have made over here. Okay. Now calculate the power in 100 volts. That is equal to voltage multiplied with current. So current is 10, voltage is 100. So the power in 100 volts is 1000 watts. Similarly, you have 80 volts over here, and current, it is flowing opposition to the given assumption conditions. You can take an assumption that current is flowing from higher potential to lower potential, and in the given circuit the current is flowing from lower to higher. That is why we have taken here as minus 8. So this gives the value of power in 80 volts as minus 640 watts. Also, we have made an assumption that X is flowing in 15 volts from lower potential to higher potential. That is why whatever the result we got as 2 amperes, that we am taking as minus 2 multiplied with 15 volts will give you the value as minus 30 watts. Therefore, power absorbed by the three circuit elements is 1000 minus 640 minus 30, which is equal to 330 watts. So this is how we solve problems related to the passive elements under power calculation. Now let us see another example based upon the calculations of power and voltage current conditions. You can see a network 1 and network 2 are given. In between network 1 and network 2, resistors are connected and source voltage is also connected. The drop over 2 ohms, the drop over 3 ohms is given as 2 and 6 volts respectively. We need to find out the power delivered by 5 volts voltage source. So how do we solve this problem? This was asked in GATE 2015 under set 1 for 1 mark. So the same assumptions what we have done for the above problem, that is in problem 2, we are going to analyze the same way for this problem 3. So the solution starts with, I have network 1 and network 2, where you can see here 2 volts and 2 ohms. If at all I assume the current to flow from network 1 to network 2, then the current would be 2 volts divided by 2 ohms will be 1 ampere, and similarly 6 volts divided by 3 ohms from network 2 to network 1 would be 2 amperes. And let us assume that X is the current which is flowing from network 2 to network 1, that is in 5 volts, that is X amperes. We need to find out the value of this particular current. So what are the assumptions we made? That is based upon the given data. That is 1 ampere it is flowing from network 1 to network 2, 2 amperes which is flowing from network 2 to network 1, and we have assumed X current which is flowing from network 2 to network 1. So I apply KCL either of these particular networks. So I'm going to get X plus 2 equal to 1. X plus 2 equal to 1. How? If at all you consider network 1, 2 amperes and X amperes are incoming, 1 ampere is outgoing. So this equation holds good. X plus 2 equal to 1. Similarly, if at all you concentrate on network 2 as particular node, you're going to get 2 amperes plus X amperes is equal to 1 ampere. So either way, you can derive this particular equation. Hence, X will be equivalent to minus 1 ampere. And that 1 ampere in minus, that is direction, that is obtained in either ways as opposite. It is flowing in this way or in this way. Therefore, power which is equivalent to voltage into current, if at all you apply, the power delivered by 5 volt voltage source is minus 1 into 5, that is equal to minus 5 watts. In the next question, you can see the effective inductance of the circuit across the terminals AB in the figure shown below. You have 4 henries, 5 henries and 6 henries as the self-inductances values, whereas the mutual inductance 1 henry it is placed between 1, that is 4 and 5, 2 henries is placed between 6 henries and 5, and 3 henries is placed between 4 and 6. So options are given like this. So we need to find out the effective inductance. This problem already we have solved in our previous magnetic circuit classes. Please check into the solution. Otherwise, you follow this solution. And this was the question asked in GATE 1998 for 1 mark. So the solution is L is equal to L1 that is 4, L2 that is 5, L3 that is 6 minus 2 times of M12 which is placed between 4 henries and 5 henries, and the dot convention is opposite direction, that is why it is minus 2 M12, and you have plus 2 M23. Between 2 and 3 you can see in both the directions of the inductors the current is assumed to be flowing uh, away from 5, away from 6, that is why it is 2 and 2 3. Whereas 4 and 6, if at all you consider, the dot is placed before 4 and this dot is placed after 6, that is why it is minus 2 M3 1. So substitute the values from the given circuit. You're going to get 4 plus 5 plus 6 minus 2 times of this 1 plus 2 times of this 2 minus 2 times of this 3 will give you the value as 11 henries. So option C is the right answer. Similarly, in GATE 1992, it was asked for 1 mark, the effective inductance between A and B. Apply the same principle and the dot convention. You're going to get the value of inductance as 8 henries. Please comment in the chat box whether you are able to get the same answer or not. And for the solution, you can look into our previous videos under magnetic circuits. Let us go with the next example. Two identical coupled inductors are connected in series. The measured inductances for the two possible series connections are 380 microhenry and 240 microhenry. Their mutual inductance in microhenry is dash. This was asked in GATE 2014 under set 2 for 1 mark. So how do you solve this? For the standard solution, you should remember that when inductors are connected in series, based upon cumulative coupling or differential coupling, the total or effective inductance is given by L1 plus L2 plus or minus 2M. Since the two possible connections are given, let us assume that L1 plus L2 plus 2M is equal to 380 microhenries and L1 plus L2 minus 2M is equal to 240 microhenries. So we need to find out the value of mutual inductance. So what I'll do, I'll take the negative negative over this L1 L2, positive over this M, and minus over this two amplitude values. So 4M is equal to 140 microhenries. In fact, M will be equal to 35 microhenries. So this was asked for 1 mark. There was no negative marking for this. So the option, it is not given, and hence you can directly write the value as 35 microhenries. In the next question, a segment of a circuit is shown in figure. You can see in this figure, you have VR equal to 5 volts, VC over here equal to 4 sine 2t. We need to find out the value of voltage across inductance, and the inductance value is given as 2 henries. So this was asked in GATE 2003 for 1 mark. Very good question. The options were given as A 3 minus 8 cos 2t, option B 32 sine 2t, option C 16 sine 2t, and option D 16 cos 2t. So how do you solve this problem? First, take the data given. We have VR equal to 5 volts. So you have VR placed over 5 ohms. VR value is 5 and resistance value is 5 ohms. Hence 1 ampere will be flowing in 5 ohms from top to downward direction, assuming to be at higher potential on this side. So this I am taking as equation 1. Also, from the given data, VC is equal to 4 sine 2t. I am taking this equation as 2. And I am going to apply KCL at this node shown over here. So the red dot over this circuit or network is shown as dot over here, and I am going to apply KCL at this node. So observe the incoming currents and outgoing currents. So 1 ampere it is flowing in 5 ohms. So it is entering towards this particular node. Also 2 amperes is flowing towards this particular node. And since BC is positive is over here, negative over here, so current I'll assume in this directions according to the given data. So the current in 1 farad is in this direction, current in 2 henry is in this direction, and by applying KCL I'm going to get 1 plus 2 equal to IL plus IC. In fact, if you solve this, you will get 3 equal to IL plus IC. Let us frame this equation as 3. Also, we know that the current through capacitor is equal to C dV by dt. In fact, V is nothing but VC and its given value is 4 sine 2t. So I'm going to apply the values which are given in the data. So C d by dt of 4 sine 2t. C value is 1. 4 is taken outside. Differentiation of sine 2t is cos 2t multiplied with 2. So this value will be obtained as 8 cos 2t. Now I am framing this equation as 4 and substituting equation 4 in equation 3. I am going to get IL which is equal to 3 minus 8 cos 2t. Now once I am going to get the value of IL, my interest is to obtain the value of voltage across inductance. So framing this equation as 5 and forming the voltage equation through inductor which is equal to L di by dt. I is nothing but IL. So L value kept as it is, d by dt of 3 minus 8 cos 2t. So differentiation of this particular parameter will give you the value as 2 times of 0 minus 8 of minus sine 2t multiplied with 2. Cos derivative is minus. So I'm going to get the value as 32 sine 2t amperes. In fact, option B is the right answer. So this is how the previous gate bits were asked for 1 marks. I hope you like this class. Please subscribe to my channel and please press the bell icon for the future notifications.